Today's lesson is going to be on how to find the inverse of functions. So the first thing we're going to talk about is some of the definitions of what an inverse is. So if you think back to Algebra 1, we talk a lot about inverse operations, which are operations that undo the previous operation. For instance, if you multiply by 8, you divide by 8. If you add 4, then you subtract 4. Square roots and squares, those are inverse operations. So that's what an inverse function is. It's a function that undoes the previous one. So some of the definitions for inverse functions is interchanging the first and second coordinates of the ordered pair. Inverse notation is f to the negative first of x. And notice a lot of times we use negative exponents. It means division. When it's a function, it means inverse. Domain of f and the range of the inverse must be the same. Essentially what domain inverses are is you flip the x and the y. You flip the domain and you flip the range between the function and the inverse of the function. And this last bullet point here is if you want to check to see if two functions are inverses, you do a composition, which is what we talked about last class, of taking the function, you substitute another function in, you do your order of operations, you simplify it, and you'll always get reduced down to a x. Okay? So now we're going to look at a couple of examples. So just some really basic ones. It says find the inverse of a function informally and verify. Informally just means take an educated guess. So if I start out with the function f of x equals 8x, well, what do I do there? Well, I'm multiplying by 8. So then what I would do is I would say that my inverse in function notation would be x over 8. Then what we do is we come down here and we check. So how do we check? We do a composition. We take the original function 8x, but instead of x we replace it with x over 8. We do our multiplication. This is really 8 over 1. The 8's cancel, and you get x. That right there shows that those two are inverses of each other. All right. Here, we would think that the inverse would be x minus 8. We're adding 8, so we subtract 8, and it does check out. So then I go to example 2. It says, which of these functions is the inverse of f of x equals 7x plus 4? Well, if I look at this, I'm adding 4, so that means I'm probably going to need to subtract 4. Well, there's a subtract 4. I'm multiplying by 7, so I probably need to divide by 7. There it is. So the correct answer would be A. All right. We're going to skip over the graphing section, and then we're going to look at how to find inverses by doing algebra. So here's a 6-step process. The universal line test just determines if the inverse is a function or not. Okay, we're not going to spend a whole lot of time with that part. We're going to spend most of our time with 2 through 5. Replace f of x with y. Interchange the x and y. That's the domain piece from the first definitions. Solve for y, and then change it back to inverse notation. And then 6 is a check. Do the substitution to see if it actually works out. So let's go for the first example. Okay, and I'm going to get rid of this graph here because we don't need the graph. I don't know why it's there. Okay, so we're going to take these two and we're going to find the inverse. So we're going to take this first one, f of x equals negative 4x minus 9. Step 1 is rewrite with a y. Step 2, switch x and y. So I'm going to switch x and y. There's step 2. Step 3 says to solve for y. So I'm going to solve for the y here. So I'm going to add the 9 over. X plus 9 equals negative 4y. Then I'm going to divide by negative 4. Divide by negative 4. And then the last step says to write it in inverse notation. So I'm going to write it in inverse notation of f of x to the negative first equals negative x minus 9 over positive 4. All I'm doing is I'm moving this negative up to the top by dividing it up there, and then that changes all your signs. And that's the inverse. Okay? So now we're going to do the same thing with this one. So it's going to be y equals the cube root of 10 minus x. Now I forgot to put function notation in there. It's actually g of x or f of x or whatever you want to call it. Switch the function notation with y. Step 2 says to switch x and y. So it's the cube root of 10 minus y. Now I'm going to solve for y. So I'm going to start solving. I need to get rid of this cube root. So I'm going to cube both sides. So I get x cubed equals this, not the square root anymore. We got rid of it. be just 10 minus y. Now I'm going to subtract the 10 to the other side. So I get negative y equals x cubed minus 10. Then I don't like that negative here, so I divide by negative 1, divide by negative 1, and then the inverse notation is negative x cubed plus 10. Divide that negative 1 up, and it becomes negative there, positive there, and my final answer is negative x cubed plus 10. And those are my inverses, and then you can check it too. Okay, here I'm going to kind of skip some steps. I'm going to take y, put that there, and then switch. X equals 6 parentheses x minus 2 squared plus 6. It's supposed to be y there. Now I'm going to solve, move the 6 to the other side, divide by 6 equals the square root y minus 2 squared. Square root both sides, and remember when you square root both sides you have to do plus or minus. Square root here, that gets rid of that, so you have y minus 2 equals plus or minus the square root of x minus 6 over 6. Add the 2 over, and you get your inverse to be the inverse of 2 plus or minus the square root of x minus 6 over 6. Now that's the inverse. Now the next part says find the domain. So what do I need to do? What issues do I have with this domain? Well, this square root can't be negative. The only part that's going to make this square root negative is if this x minus 6 is negative. So then we say x minus 6 has to be greater than or equal to 0. X has to be greater than or equal to 6. On the number line, there's 6. Anything left over here is bad. So then my domain would be bracket 6 to infinity. And that would be your domain. And then the last example, and I'm going to tell you right now that this example, there's one just like this on the test. So we do our switch, x equals 4y plus 1 over 6y plus 7. And what happens here is most people are like, oh my goodness, there's a fraction and there's two y's. Right, there are. That's why this is a trickier problem. So remember, if I'm solving an equation, I don't like to solve with the equations with fractions, so I got to learn how to get rid of fractions. A fraction is division. You get rid of it by multiplication. So I multiply both sides by 6y plus 7. They cancel here. On the right-hand side, I distribute 6xy plus 7x equals 4y plus 1. Now I'm solving for y, which means if I'm solving for y, then I need to get all my y's on one side. So I need to get this 4y to move over. So I'm going to get 6xy minus 4y equals negative 7x plus 1. I want this 7x to move over here, so I subtract it over. Now here's where a lot of students don't see the next step. And I understand why. So I'm solving for y, which means I need to get y by itself. Here's how you do it. Both of these have a factor of y, so I factor it out. And I get 6x minus 4 equals negative 7x plus 1. Now what do? I divide the 6x minus 4 over, and my function becomes the inverse of 7x plus 1, that's a negative 7x plus 1, over 6x minus 4. Then the domain, okay, well, the only issue is a 0 in the denominator, so I set 6x minus 4 equals to 0. Solve that, and I get x equals 2/3. So that means negative infinity to 2/3. The union 2/3 to infinity. And that would be your domain.